What is fatigue? Fatigue is typically described as decrements in muscular performance with continued effort accompanied by general sensations of tiredness. An alternative definition used in research studies to quantify fatigue is the inability to maintain the required power output to continue muscular work at a given intensity. The fact that fatigue is reversible by rest distinguishes it from muscle weakness or damage. Within this video, we are going to talk about 4 underlying causes of fatigue. The first underlying cause is a decreased rate of energy, more specifically ATP and PCR and anaerobic glycolysis. The second underlying cause is the accumulation of metabolic products, more specifically lactate and hydrogen ions. The third underlying cause is the failure of the muscle's fibrous contractile mechanism. The fourth underlying cause is alterations in neural control of muscle contractions. Within the first underlying cause, here we are going to specifically talk about PCR depletion. PCR is used for short-term high-intensity effort to rebuild ATP as it is used and thus to maintain ATP stores within the muscle. Although ATP is directly responsible for the energy used during such activities, it is depleted less rapidly than PCR during muscular effort because ATP is being produced by other systems. As PCR is depleted, the ability to quickly replace the spent ATP is hindered. At exhaustion, both ATP and PCR may be depleted. Training and experience allows the athlete to judge their optimal pace that permits them the most efficient use of ATP and PCR for their entire event. Still within the first underlying cause, the next thing we are specifically going to talk about is glycogen depletion. Muscle ATP concentrations are also maintained by the breakdown of muscle glycogen. In events lasting longer than a few seconds, muscle glycogen becomes the primary energy source for ATP synthesis. Muscle glycogen is used more rapidly during the first few minutes of exercise than in the later stages. The sensation of fatigue in long-term exercise coincides with a decreased concentration of muscle glycogen. Take marathon runners for an example. Marathon runners commonly refer to the sudden onset of fatigue that they experience at 29 to 35 kilometers as, quote, hitting the wall. This quote of hitting the wall is at least part of this sensation can be attributed to muscle glycogen depletion within their body. Moving on to the second underlying cause of accumulation of metabolic byproducts, the first thing we are specifically going to talk about is lactic acid. Recall that lactic acid is a byproduct of anaerobic glycolysis. Although most people believe that lactic acid is responsible for fatigue, lactic acid undergoes constant turnover and is recycled to provide energy. Lactic acid produced within the cytoplasm of a muscle fiber can be taken up by mitochondria within that same muscle fiber and oxidized for ATP formation. Lactic acid can also be shuttled to other sites where it can be oxidized. Short sprints in running, cycling, and swimming can all lead to large accumulations of lactic acid. While the presence of lactic acid itself cannot be blamed for the feeling of fatigue, if it is not cleared, the lactic acid dissociates, converting to lactate and causing an accumulation of hydrogen ions. Still within the second underlying cause, the next thing we're specifically going to talk about is hydrogen ions. With lactic acid converting to lactate and causing an accumulation of hydrogen ions accumulation can cause muscle acidosis, which is a decrease in pH. Because of the body's buffering capacity, the hydrogen ions concentration remains low, even during the most severe exercise, allowing muscle pH to decrease from a resting value of 7.1 to no lower than 6.4 at exhaustion after high-intensity activity. pH changes of this magnitude can adversely affect energy production and muscle contraction. Because of these effects, low muscle pH may be a primary cause of fatigue during exercise. Within the third underlying cause of failure of the muscle fiber's contractile mechanism, the first thing we are specifically going to talk about is neuromuscular fatigue. As a whole, fatigue may result from the inability to activate muscle fibers within the body. Nerve impulses are transmitted across the neuromuscular junction to activate the fiber's membrane, and it causes the fiber's sarcoplasmic reticulum to release calcium. The calcium in turn binds with troponin to initiate muscle contraction. This process is collectively called accentuation contraction coupling. If this process cannot be completed, the body may result in little to no muscular contraction, therefore resulting in fatigue. Within the fourth underlying cause of alterations in neural control of the muscle contraction, we are specifically going to talk about neural transmissions. Fatigue may occur at the neuromuscular junction, preventing nerve impulse transmission to the muscle fiber membrane. Studies establish such a failure of nerve impulse transmission in fatigued muscle. This failure may involve one or more of the following processes. The first process is the release or synthesis of acetylcholine, the neurotransmitter that relays the nerve impulses from the motor nerve to the muscle membrane might be reduced. The second process is cholinesterase might become hyperactive, preventing sufficient concentration of acetylcholine to initiate an action potential. The third process is cholinesterase activity might become hypoactive, allowing acetylcholine to accumulate excessively, inhibiting relaxation. The fourth process is the muscle fiber membrane might develop a higher threshold for stimulation by motor neurons. The fifth process is some substance might compete with acetylcholine for the receptors on the muscle membrane without activating the membrane. The sixth and final process may be potassium might leave the intracellular space of the contracting muscle, decreasing the membrane potential to half of its resting value. Overall, fatigue may result from many things. The first two things we talked about were the depletion of PCR or glycogen, which both impair ATP production. The next two things was the accumulation of lactic acid and hydrogen ions, which may decrease muscle pH, resulting in fatigue. The next thing was the failure for muscle contractions within the body. And the last thing was the CNS not being able to activate or transmit, therefore resulting in muscle fatigue.